Welcome to OWASP, specifically the Atlanta chapter. My name is Guled. I'm one of your chapter leaders here. Uh, Joining me today is Thomas, my other co-chapter leaders. There's four of us that represents Atlanta. Please reach out. Anytime we are your chapter leaders, we're here to support you. We're here to engage with you, uh, and do anything that we can do to help you build more secure software. All right. Welcome. As I said, we're the Atlanta chapter for OWASP. For folks that are just joining us, tell me, is anyone new here? Is this your first time joining us for the Atlanta chapter? You can always just thumbs up or say hello in the chat. Always want to gauge who's new. Got a couple of new folks. Welcome, Pablo. All right. Well, welcome. Like I said, we are OWASP. Um, for the folks that are new, OWASP is a global nonprofit. So we're the Open Worldwide Application Security Project. We are a very large organization, an international organization with chapters all around the world. From the chapters that we build, from the projects that we do, the standards we create to the educational resources, we're here to build more secure software. So if it's from web apps, from the start of it and how to build them, how to design them, how to architect them, to all the way to agentic AI, how do you lock down these MCP servers? How do you lock down these sort of coding pipelines and such? We're here to help you do that. So if you are just starting out, you have no idea where to begin, we have cheat sheets, we have beginning materials, or if you're all the way to a Fortune 10 company and you're trying to figure out how to scale up your programs, we have materials, we have standards, we have guides, we have tools to help you build more secure software. So definitely check us out at owasp.org. Check out all our amazing projects. Come to our meetups, come to our conferences, engage with us. All right. So, OWASP, we are a nonprofit, a 501(c)(3), all run by volunteers. So your support helps us helps to make these projects happen. So definitely your manpower, join us, become a member. I think it's like $80, $60, $80 a year. It's really cheap for an entire year. Donating always helps a lot. And just engaging with us. So we have a meetup. Come to more meetups, come in person. We do hybrid. This is the first time in a long time we're doing virtual only, but definitely come in person if you can, especially if you're in the Atlanta area or if you're traveling through. And if you want to contribute, again, like I said, it's completely volunteer driven, volunteer run. So if you want to contribute, reach out to us. We appreciate new projects. We appreciate people proposing new ideas and talks. We definitely want to host it. We definitely want to hear from you. We definitely want to share that out. So just email us, atlantaleaders@owasp.org, to connect with any of us. As well, as an Atlanta chapter, one thing we do is we usually host the Atlanta Cybersecurity Engineers Holiday Party. So this big, wide, citywide holiday party that we are the core sponsors of and hosts. And we're trying to do it again. I think we sold out with over 200 people that came through last year. Completely sold out. So hopefully we're trying to make it bigger and make sure everyone can be able to join us. So we are, as a completely volunteer run, volunteer driven, donation driven organization, do always reach out and need sponsorship. So if your company is interested in supporting in any sort of way, definitely reach out. We're looking for venues and for people, organizations, groups in the Metro Atlanta area that's interested in collaborating on this holiday party, definitely reach out to us. Now, before we get into this talk, next month, we're actually going to be having a talk additionally around AI, how AI is being used, how it's developing insecure applications, and how you can spot it, mitigate that, and hopefully prevent that in the future. So we'll have Chris Lindsay. It'll be on July 24th, and I believe it's actually hybrid. It's going to be hybrid, so still locking down those details. But yeah, it's going to be happening next month. Please join us. Now, let's jump into it. Today we have Dawson. Dawson is a badass engineer coming from Toronto. So I'm just going to toss it over to Ads.
Cool. Thanks, Gilad. Hey everyone. Thanks for coming, taking your time today. I hope you enjoy. So I'm Ads. I'm a AI security researcher at Dreadnode. Our mission is to advance the state of offensive security. We kind of focus our research on discovering emerging attack vectors, novel testing approaches, and like creating scalable solutions. Thanks to the OWASP Atlanta chapter for hosting me and putting on this cool event. Happy Juneteenth as well. And I'd also like this to be like as interactive as possible. Don't want to like bore people here. So like honestly, if you have a question or something isn't clear, then please like just like raise your hand or ask a question or something. And yeah, definitely just kind of make it more interactive if possible. Yeah, so a bit about me just really quick. I started out as a network engineer, which is ultimately how I got into network penetration testing. I got like really addicted to hunting web apps and like spending a bunch of time on bug bounties. I guess my fork into AI was probably about 3.5 years, 3 years ago. I worked at a foundation model company in Canada. So basically a company that builds models, and not just limited to, but I built a security team, the tooling. It was super insightful to me because I was very focused like on product security and enterprise security. So I was very much familiar with like SDLC, code reviews, things like that. But I got really good insights into the model development lifecycle, and then obviously like deploying models in like SaaS and APIs and things like that as well, right? Which is kind of what we're seeing like rapid adoption of right now. Part of like my role there was to do like a lot of AppSec and red team efforts. I guess I have quite a lot of DevSecOps experience of building up their blue team infrastructure. Aside from that, I'm tech lead for the OWASP LLM Applications project, a founding contributor of the OWASP AI VSS, which is another initiative for the artificial intelligence vulnerability scoring system. And I'm also a proud member of our Toronto chapter here as well. Cool. Like, I hope this is fun. We're going to talk kind of about how to hack AI, but and also using AI to hack. The aim of tonight is that I want to inspire you, educate you, equip you with some of the awesome stuff we're building at Dreadnode. It's open source, a lot of it, so please don't take that as a sales pitch. And I'll also make the slides available. First thing I'm going to cover rigging, which is our LLM interaction framework. Because obviously, regardless whether we're hacking AI or using AI as like defensive agents, we need a way to interact with models. So yeah, rigging is our LLM interaction framework where we can interact with underlying LLMs or just any function which completes text. I'll dive into our strikes platform for offensive agents, doing evaluations or evals, and then um, I'll showcase our recently published paper and benchmark, which is AI Red Team Bench, which actually got published yesterday, which is
Ads.
pretty cool.
Sorry for interrupting. Are you sharing your screen?
Oh, dude, I'm so sorry.
Okay, thank you.
Sorry, I thought I was still sharing from beforehand. Cool. Can you see it now?
Yes, we can.
Okay, great start to the evening. So, yeah, sorry about that, guys. Uh, there was my little who am I? And tonight's rundown. So yeah, we're going to go through rigging, strikes, which is our like cyber evaluations platform, Crucible, which is our AI ML CTF platform, and then AI Red Team Bench, which is a evaluation framework, agent, benchmark, data set, and paper that we published yesterday. Cool. So yeah, basically first things off. So rigging, like I said, is our open source lightweight LM interaction framework. You can grab it via PyPy. It uses light LM under the hood, which gives you like a default generator, which gives you access to like a bunch of models. The model section is really vast. We commonly term provider models as generators, which are basically strings used to define an LM or underlying component that completes a function to return text. So like O3 Mini or like GPT-4, as you can see in this slide here. Like major components about rigging, which I think makes it great. It allows you to find to define prompts as Python functions. It's got some really simple tool use, even for models who don't actually support them at their own API layer. Rigging also integrates with Logfire, which exposes like really useful tracing of information. And it's with the OTOL standard, where you get like structured, reliable, and consistent abstractions. I'm also going to call out the fact that one reason why I really do particularly like rigging, or why I do think it's good, is that it uses rigging under the it uses Pydantic XML under the hood, which is built on Pydantic. So if anyone's ever read the blog from Anthropic of how they recommend prompts in Claude, they always recommend structuring prompts in XML tags. Rigging favors XML to combine unstructured and structured data when generating text with an LLM, especially for like raw text. It exposes a model base class, which is like basically a lightweight wrapper around Pydantic XML's base XML model, with like some added features and functionality, which makes it easy to manage and rigging. The reason why we use XML is when you use JSON, the entire message has to be JSON, and it includes like a lot of escaping, and it's kind of messy, which models aren't used to, and seems to like break the tokenizer very frequently. XML is fundamentals. XML is fundamental because it lets models produce both natural language and strictly validated structured outputs, allowing that free flow in semi-structured text. So when it comes to rigging, we have a concept of chat and chat pipeline. Traditional like LMs are interactions are unstructured. Like you send text and you get text back. Rigging has a concept where the result of chat as pipeline. So the naming might be confusing, but chats go through like two phases where we first stage them into a pipeline, where we operate and prepare them before we actually trigger generation with a run. Both chat pipeline and chat objects provide freedom for forking off the current state on messages or continue a stream of messages after generation has occurred. So a chat pipeline is basically like structured LM interactions. So instead of getting like messy text in and out, you get predictable types responses. You define what you want, and like the pipeline guarantees you get it in the right format. Rigging also uses async functions because LM API calls are network operations that take time, right? So like using the await, we can wait for this API response before continuing, like calling a slow web API, for example. It's important when chaining operations that they need to wait for the previous next step. If anyone's done like network operations or just maybe like web application bug hacking, a lot of your steps you're like taking like methodical approaches and you're waiting for one step to complete before you do the next, right? Same as if you were doing something like brute forcing, which is why like async functions are really important there. Rigging also supports prompt caches with like support providers, which means that a lot of like the token usage gets decreased by that. So obviously it's saving you a bit of a bang for your buck as well, right? Cool. So kind of like one of the main reasons I'm sharing rigging is that a lot of this will make sense shortly. But we've made some like major enhancements to rigging as of version 3. So tools and rigging allow language models to call functions and need to interact with external systems, execute code, like perform well-defined tasks during generation. Rigging introduces V3 introduces a unified tool system, which makes it easier to define tools where the same tools work across different providers and calling conventions. So like a completely well-structured universal output. We use this tool decorator, which you can see here, where we validate inputs before executing to prevent command injection. And the using parameter controls how rigging interacts with language models for tool calls. So you've got like auto, API, XML, or JSON and XML, which means that you can like use different tools in different formats. And the max depth parameter basically is like almost like a stopgap, which prevents the LM from getting like stuck in an infinite loop, for example. So you can like put a cap on that action. Cool. So I don't want to kill everyone with a slide overview. I hope a lot of it is kind of making sense or sounds pretty familiar so far. But I'm going to jump into a demo with rigging. It still works, but it's actually not using any tools, which is kind of why I talk about it, I guess, kind of old school. Like, so let me just run through. Is most people common with DVRA, which is down vulnerable restaurant application? It's basically, for anyone who's not aware, it's a intentionally vulnerable API. So it's meant for education purposes, stuff like that. So what we're basically going to do here is, oh, can everyone see that okay? Guled, is like that resolution all right?
Yeah, I can see it. Does everyone need a little bit bigger?
Consensus, that's a bit better.
Okay, that's
No,
great.
I think it's readable. It's fine.
It's readable.
Cool, sweet.
Okay.
Okay, awesome, cool. So basically what I'm going to do, I've already downloaded, I've already cloned Downloadable Restaurant API game. So we're going to start the game here, right? And basically what we're using rigging to use basically hook up the agent with access to this downloadable restaurant app. If anyone's done it beforehand, this will feel like very familiar when you're going through this. So effectively what it is, it's a sequence of challenges, which are like go from kind of like an easy through moderate and difficult challenge setting. But yeah, we're going to task a model with this. So let me just quickly walk through a few bits of the code here. So effectively what we're doing is we're just using a very simple like CLI entry point here. So we have like an action-based architecture. So we're using a lot of classes, as you can see here, where we're using this XML format where we can give the agent like really important tasks here. So, you know, pin to top, delete memory, recall memory, save memory. So all these are like structured XML classes, which allow the agent to store certain parts so it can complete the task end to end. So the agent execution loop is where it follows a predict execute cycle. So the LM receives the content, generates actions as XML, which are then passed, and then results are then fed back into the model. So it's kind of almost like as if you were a human, we're inputting commands and getting responses, right? So I actually have, because I had a few demos, I've actually done a kind of a copy and paste there. But effectively what we're doing is we're just calling the base URL, which is our down vulnerable restaurant application at the moment. I'm going to actually traffic some proxy traffic there. Going to proxy some traffic through BERT. So you can see, for example, like just kind of show you guys what that would look like. And then there's a generator here we're using like Meta Llama 4 17B. So if the demo gods are good to me here. Sorry. I'm going to use a default generator here. I must have a problem with my code. But yeah, so effectively what we can see here is we're basically seeing like an interaction between Llama 4 and the user. So these steps are all logged here. You can see that like the agent is like performing like simple tasks, which we would be as if we were like hunting a web application, for example, right? So it's first of all, you can see that it's looking for like API documentation, so you can find like any unexposed endpoints. It's then looking for things like Swagger files. Effectively, it's getting a lot of 404s here, but you can kind of see the methodology of where it's taking this approach, which is very much similar to the way that like any other model, any maybe human may like approach this, right? So we keep seeing here, we can see effectively how far it gets, but we can see like specific output here, which is coming like the API specification provides detailed information about the endpoint. So like these are all information. It's storing pieces of information which it's finding from there, and then it's able to then use that in that same chat pipeline that I was talking about in later parts of its results, right? So also just to kind of give you an idea here. Oh yeah, Daniel, DVRA is very similar to DVWA. The difference is that DVRA actually it's actually kind of cool. I did it when as soon as it came out, actually, like a long time ago. But it basically because you have access to the source code, the other set of the challenge is to actually then fix the code. And then you can see here it says fix and validate the vulnerability, then it actually then validates your secure code. So you're getting like the exploitation and the secure code piece, which I actually kind of like that. It's really good, especially for like educational stuff, right?
Can you show the slide or provide the link?
Yes, spare me 2 seconds because I was actually just about to show you, for example, like what you would see in Burp. So you can see before that I was like proxying that traffic through Burp Suite. I assume a lot of people are familiar with this. If not, I apologize. But you can kind of see the results. Like this is all like kind of web traffic, which is coming from the agent and the responses. So you could also use this for whatever purpose you may need as well. But let me share the slide again. Cool. So yeah, now I guess I was going to do like a quick demo of MCP and a tool called Road Pages. Is anyone like unfamiliar with MCP? Sorry, you probably need to speak up because I can't actually see if anyone's raised a hand. But no. So MCP is a open standard for language models to interact with external tools and services. It's really similar to the Swagger Open API schema for APIs that interact with one another. It's basically a unified schema that is agreed upon, and then rigging supports a native MCP client for both server-side events and standard input-output. Server-side events are like commonly what you're seeing on like remote endpoints, and then standard input-output is literally like a process on your machine, right? I'm also going to cover this tool called RoboPages, which is another one of our open source no code and simple setup for a tooling server, which basically hosts offensive and defensive cyber tools. So the RoboPages CLI is a function calling server which hosts the tools directory on localhost, and individual RoboPages are standardized YAML files describing a function, aka a tool to the model. So each individual RoboPage, if anyone's heard the term man pages, it's meant to be RoboPages and like manual pages for robots. But yeah, the individual row pages are standardized YAML files, which are described as a function, aka a tool to the model. And then, for example, let's say like Nmap, where you have several functions, such as the TCP scan. So actually, let me just show you that real quick. And each robo page uses a remote or locally built Docker container. So it's all executed from a container on local. So let me actually just give you guys an example here, sorry. So the reason why I'm covering this in the same slide is that you'll see it's actually very similar to MCP because effectively all it is, it's a standard, a standardized approach to providing models access to tools. So I look here. So these are all the individual robo pages. You can throw a pull request in here if you want. You can git clone the repo and pretty much get started. But like for example, if I just take like an example here, there's an Nmap robo page. So this is a robo page. So effectively it has like metadata, which is common across every single one. So like if we expose Nmap, which I assume a lot of people are familiar with here. And then within here, we have a concept of functions. So we have like TCP SYN scan, the command line inputs, and this is the way that's built on the doc file. Then we have one for like UDP. Effectively, this is like completely non-limited in the fact that you could create hundreds of these different functions with Nmap if you wanted to. And the whole point of it being open source is that it's I guess like a community contribution there. So let me just go back here. So Sorry, guys, it's quite difficult to switch so many screens when you're remote. I appreciate you bearing with me. Cool. So I'm going to go back to this previous example here. And I'm just going to shut down this guy. So just give me 2 seconds. Cool. So now basically what I'm effectively doing here, I apologize for being quiet. I struggle with multitasking. But effectively what I have a very simple fast MCP based MCP server exposing a weather tool, and we're going to use rigging to hook up the underlying model to check real-time weather. And then I'll do a quick example for robo pages here as well. But if I show the tool, it's really simple. Like there's effectively not a lot of code exposed in here at all. There's some logging enabled, which you can pretty much ignore. However, I just expose an MCP server, which is this guy here. I'm effectively creating a chat pipeline where I'm asking the model to use the tools available to tell me the weather in Atlanta. Obviously, this is, again, non-limited, but this is just to give you an idea, right? So on the right-hand side, I have the MCP server running, and then I'm just going to run my Python code here. And I can start see the request that's coming into the server. These are just basic server logs, right? And effectively, we've completed the chat pipeline here with like O3 Mini, gives you the user assistant, and then it gives you the response. Like this is a very simple example, but you can get an idea. I'm sure a lot of people who are kind of following MCP, there's MCP servers for like Burp Suite, OWASP Zap, like there's a huge amount. So like it's pretty limited that way. So yeah. So what I'm going to do now is that I'm actually going to go through robo pages, which I personally quite like because I mean I guess I'm biased because I spent quite a bit of time contributing to it as an open source tool. But yeah, so effectively what we're doing here is that I've already installed robo pages. Obviously, I'm just using the robo pages serve, which is effectively spinning up the server. As you can see, it's pre-building all the containers, and all these containers are the robo pages, which I was showing you earlier when we had like Nmap, for example. So a lot of these hopefully should seem familiar to you again. So you got like Katana, Graph Finder, GoBuster, Ferox Buster. A lot of these WP Scan, SQL Map, a lot of these are like very common security tools. Obviously, we favor security tools because at Dreadnode, we like hacking and it's much more fun, right, than a weather tool. But you get the idea. So also just to give you like another idea, I guess, because we've actually got the robo pages server running here, I can give you an example of what it actually looks like. So this is like basically all robo pages is doing is exposing an API server with a bunch of offensive security tools to a model. And you can see from the robo pages, the Nmap example that I showed you here, you can see these example functions which are defined. So for like these ones here, these are all individual functions. So we've got like Zap Scan Host OS app, run a baseline target with Zap on a host app. We have like numerous of here, like Google Dorking, for example. Okay. So now if I go to the code we have here, so that, again, this is rigging code. You don't have to use rigging. This is just using rigging as an LLM interaction framework, for example, right? So again, it's got some basic logging, but pretty much in my main function here, all I'm doing is using the native rigging RoboPage integration. I'm using a generator. Again, I'm using O3 Mini. All I have to do is plug in my OpenAI API key. And then effectively all I'm doing here is saying use the available RoboPages tools presented to you in order to enumerate open ports and localhost and return the results. Obviously, I'm doing like localhost because it wouldn't be really ethical to do like a recorded meeting and start like hacking like live web applications. But I'm hoping that this kind of gives you the idea here, right? So as you can see here, I'm just running the code. You can see that the model instantly fetched 49 functions from the RoboPages server, which is kind of what I showed you up here earlier, which is exposed via that Swagger. These are all the individual functions that it currently has at the moment. So it has all these tools available. So it's going to look through these tools and the function definition in here, and it's going to use one of those, which we don't know because it's because obviously it's a model. It's unpredictable output, so to speak, that it's going to pick one of these to perform the task in hand, right? So like kind of obviously like it goes to default with mmap, but you can see like the model response here. This is the response coming from the model, where the model is being given these individual responses. So the model is just literally coming from OpenAI's API in like and using it via rigging, executing that and returning that. And in this case, obviously, like I'm just scanning my own local host, right? Also, what we can do here is that I also did just like another really simple one. Another really simple script here, which is this list RoboPages. So categorize and order available tools by the usefulness of purple in markdown format and grouping categories and do not exceed 1,000 characters. So here again, the model is literally just getting all the functions from the RoboPages server, responding this. So hopefully kind of giving you an idea of early with that like chat pipeline, you can use all these integrated tools and create like a full, I guess like a full end-to-end network operation almost with this kind of structure. Is there any questions or anything so far? Anything not making sense? Anything unclear?
Yeah, just a quick question.
Yeah, please.
So essentially, you're using AI
Mhm.
and you're using the MCP protocol to connect up to RoboPages, and RoboPages just gives you access to a large tool set to essentially have the AI model actually do the vulnerability testing for you.
Correct. Apart from the start bit, I apologize if that was my misconstrued of it. It's not using MCP to connect to RoboPages. Think of RoboPages as almost an alternative to MCP. The MCP example was when I was just using like a weather server, for example. I just built like a weather server on a MCP weather server this afternoon, and that was my example there. The RoboPages has been going for like a long time, probably since last October. To be honest, admittedly, yeah. So we discussed RoboPages back in October 2024, and I think it actually probably would have taken off more if we'd pushed it a bit more, because we were kind of like, we have all these access to these tools and all these things are coming out. This is obviously like 6 months ago, no, probably 8 months ago. Like, wouldn't it be great if we had like a standardized definition of a way of like providing access to models, access tools? And effectively, that's what MCP is in like a very box thing. The major difference, like TLDR, major difference between MCP and RoboPages is that RoboPages functions are declared in YAML files as actions and represented a tool which is hosted in Docker containers on local host. So that's the key difference, really. Like MCP can have standard input and output, but what I'm saying is like you could effectively go into that RoboPages repo, submit a pull request, and create a new tool based on any given like Docker container that's available, or you can create a Docker container. So a lot of these tools, there's already pre-built Docker containers, for example, like triple hog scanning or SQL map or something like that. All you have to do is add that RoboPage and it automatically gets added to the available list of tools. But the rest, you're absolutely correct.
Okay, so you're using RoboPages to get access to the tools, and you're using MCP to access the vulnerable weather API service.
Yes, yeah, exactly. Yeah, just think of MCP as like in the example I showed you was like the vulnerable web weather server. RoboPages is effectively it's giving the model access to an array of offensive security tools, which MCP can do, but obviously MCP, I guess, isn't as it is mature at this point. But like, for example, it doesn't have at the time when it first started, it didn't have all these like, kind of like offensive security tools. So like, if you want to, we could use an example here and say, enumerate, let's say, use the available robo pages tools to identify the host name of local host. So effectively what we're doing here, I obviously really, sorry, wrong one. I really don't want to obviously start actually like live hacking on potentially vulnerable web applications because I mean, I'm not going to do that, but effectively, like you can see here that it's taking that decision. So I'm not actually forcing the model to use a tool here. I'm giving the model access to like a bunch of security tools and then basically letting it roam free, so to speak. All this to say that you can put parameters around these robo pages when you run it, so you can obviously like make sure that it does or doesn't have internet access. So there are ways of like isolating that at the container level, which are kind of neat. So you can effectively like not end up in trouble, so to speak. Again, you can proxy all this traffic through a proxy. So you can use Burp or Kaido or whatever you want. You can see the output is different in this time because there's actually a error with the Docker container, so that's not great. But you can see it's taking a different approach to this different task. So it's like it's structured tools, but it's not actually like it's not boxing the model into a specific tool. It's more just thinking about it if you were to install a Kali Linux distro and all the tool array of tools you would have access to. I hope that makes sense.
Yeah, so you just in some ways, I guess you really just created an assessment AI agent.
Yeah, well, yeah, I guess like rigging is the interaction framework for models, and then we're using rigging with robo pages to create an agent to do whatever task. Yeah,
whatever task that. Okay.
Yeah, exactly. Yeah.
Thanks.
No, thank you.
In chat as well.
Oh yeah. Thanks for the question, Robert. So rigging. If the question is about rigging, then we do support like Olama and those and local models. So you can use like I don't really use a lot of the applications, but you can use like Misty or Olama, or there's a bunch of like there's a bunch of tools where you can applications where you can host models locally. But yes, you can certainly use local models for rigging, so you can save yourself money on inference and stuff like that. I actually didn't plan to cover it, but I did actually build. Kind of mentioned this in one of the talks I did before. 1 second. If you're also interested, what I'd probably suggest you check out, especially if anyone's like into bug bounties and web applications. We have another tool called Burp Fronts, which is just a Burp Suite extension that I created a while ago. And that also allows you to use on-prem models. So effectively you just plug in the local model, or you can use inference if you want. And effectively you've almost got like a hacking co-pilot where you can get like security assessments and you can feed HTTP requests and response as it kind of traverse your proxy and send it to the local model as well. So I'd probably recommend you check that out if you're interested. It's kind of got me thinking when you mentioned local models. Yeah, I hope that answers that question anyway for you. Cool. So yeah, here's an example of just like what I was running earlier. When I mentioned Logfire, this is just like an OTel standard. This is a very like kind of structured way rather than looking at command line data. It gets you really close to the raw inference layer. And again, it's another like three line commands, if that you can use with rigging to expose it to a Logfire, which is great. Logfire is actually built by the folks at Pydantic as well. So I do like really rate that, to be honest. And again, like, yeah, proxy and robo pages through Burp, and it's kind of like a very similar flow to what you were seeing earlier. Cool. So I guess like in terms of like using agents, so it's pretty cool. Like, I guess you see it via the terminal or whatever, and it's like, okay, so like now what, right? So evaluating offensive security agents requires more than like just running code. You need to build systems, execute them at scale, measure interactions, target systems, and then kind of evaluate the results. So we have a platform here called Strikes. Another high level, Strikes works with like three fundamental concepts. So you have an agent library to invoke LLMs as agents, which are tasks. So it doesn't have to be rigging, but we do recommend it. You have the agent harness, which is the code surrounding the model, the tools it has access to, and the representation of its provided environment. So kind of very similar to like robo pages in that example. Way to measure and represent the data. So you can think of Strikes as a blend of experimentation, task orchestration, and observability. It's flexible to extend and it's powerful at scale. So under the hood of Strikes, we have an SDK and a UI, which allows you to deploy agents and models into your workflows. The SDK provides a flexible approach to like experiment and tasking, tracking data, logging artifacts, measuring everything with metrics throughout code, and scale your code from a single run to thousands. It also has like really tight feedback loops to train and tune agents or models. So like effectively, like what you can do is from the Strikes platform is that you can run these cyber evaluations and then take that data and then use that into like a model training pipeline as well, which is pretty cool. Oh. So I guess like the best way to get your feet wet is with Strikes is cyber evaluations. Try out some of our example agents. So I have this example agents link. Like I said, I'll make the slide available, and if anyone's interested, then please let me know, and I can kind of navigate towards that. In a second, I'll look through a demo, but I've included some simple steps which will help you get set up with a matter of minutes, like just about five commands of stuff. You just hook up your Dreadnode API key, obviously your inference API key, whether you're using OpenAI or whether you're choosing to use local models, for example, then you might not need one, right? Cool. So what I'm going to show you here is so there's some research from Google DeepMind where the agent works to solve a variety of CTF challenges, given access to execute bash commands on a network local Kali Linux container. The agent harness will automatically build all the containers with a supplied flag and then load them as they're needed to ensure they're network isolated. So you can run many parameters on this. For example, like run each challenge, you can produce P agents where P agents task where P is parallelism. So you can run multiple agents against one container at the same time. Inside each task, bring up the associated environment, continue requesting the next command from the inference model and execute it into the environment container. So again, it's that continuous feedback loop. And the concurrency flag allows us to spin up multiple generators, which means you can have multiple LLMs going ham at the CTF, right? So let me just run in here. Oh, actually, sorry, what I will do is let me just. So I was intending to do a couple of demos, so I'll just go through the next one as well rather than switch screens. It's probably a bit easier. And the next one I'll do is sensitive data extraction. So effectively what we're using, this is another example agent that we have. We just have like a bunch of example agents, which are based on domain expertise or areas of interest that we've kind of wrote up and thought they were pretty cool. What we're using here, we have sensitive data extraction. So the agents provide access to a file system tool, which is based on the FS spec for using and extraction sensitive data stored in files. So it has access to be able to scan local files, GitHub repos, S3 buckets, DCS buckets, and like a bunch of other options. The agents granted access to some maximum step count to operate tools, queries, and search files and provide reports of any sensitive data it finds. Okay. So let me just switch over again. So can you guys see the example agents repo here?
Yes, we can see it.
Sweet, perfect. Thank you very much. So actually, let me just check out the main. Sorry. Cool. So effectively, what I'm going to do first here is I'm going to show you the dangerous capabilities. So uv run -m dangerous. So I'll just kind of give you the idea of what this agent is tasked to do, and sometimes it's a bit easier to sort through the CLI. Cool. So effectively, again, what we're doing here is we're using a model. We're going to spin up multiple containers which are vulnerable web applications, databases, servers, SSH servers. There's a bunch there. These are all defined. Again, if you look through the code, they're all in here. But effectively, what we have is a JSON here, which exposes a bunch of tools. So the model's given access to a Kali Linux distribution container, and these are all the individual challenges. So there's like a SQL injection CTF, there's a command injection, there's a database one, database hard, and each one, depending on the parameter that you choose, you can actually select hard, medium, or easy, which is actually then giving them like the model a certain context. Obviously, the easier is sometimes more information or more type hints and things like that. Cool. So yeah, we can apply parallelism, concurrency, maximum steps, and then we can also do things like isolate the containers, put some memory limits on and things like that, right? So let's just run an example here. So what I'm doing is I'm literally just using GPT-4o. I'm going to use a concurrency of 2. So I'm going to spin up 2 GPT-4o agents. And I'm just going to focus on one of the challenges called SSH right now, which is a vulnerable SSH server. And I'm going to specify my Dreadnode project as well. I'll show you kind of how this looks from the UI after it's done. But when I'm kind of running this here, you can see it's building the container. So it's building the vulnerable SSH container. It's building the Kali Linux distro, and it's effectively giving the model access now. So you can see the model's actually performing these Nmap tasks. It's using Hydra. It's looking for the RockU TXT, which is a commonly used huge word list of common usernames and passwords. In this case, for some reason, it's not available, but you can see the steps that the model's kind of taking through here to try and achieve the objective. Okay. So again, we have another one called sensitive data extraction, kind of very similar approach. However, this one's built on the FS spec. So if I show you here in the README, so yeah, well, these are all the available things that we use FS spec under the hood. So we can scan GitHub repos, GCS buckets, Azure, S3, or you can scan local directories. And again, I'll kind of give you an idea of what we're looking at here. Cool. So effectively what we're going to use is we're going to use the model. We're going to choose an FS spec. So I actually found a very old repo that I had from a long time ago, where I actually set up a vulnerable repo with a bunch of just exposed secrets, which is this guy here. So this is my GitHub handle, and this is the repo here. Again, I'm going to use Llama 4 17b, and effectively I'm just going to let the model see if it can identify as many secrets on that GitHub repo as possible. Let me try a 3 mini. Again, like I said, this is all using rigging under the hood, so you can use local models as well if you like. I'm not running any right now, to be honest. One second. I think you need to. I'm sorry, I'm not sure why that's working right now. I guess to save myself I'm trying to avoid a bit of embarrassment here. What I will do is I will just kind of show you what I was I tested this earlier, so I I'm not sure what it is there, but let me just show you what this looks like from our UI perspective and trying to give you an idea of what we're actually doing here. Cool. So this is the Dreadnode platform. For anyone who's not aware, like I say, Strikes is our cyber evaluations platform. This is a run that I was performing earlier with pretty much the exact same commands. You can see that we have a concept of like tasks, traces, inputs, and outputs. We can get like a pretty nice graph, which effectively, obviously, these get more complex. The more complex these chat pipelines and these network operations look like. In here, we can see the actual individual chats as well, so we can see the raw inference that's going on with the model. So you can see the task with the system prompt we're assigning it. You can see it's starting Nmap. You can see it's got the Nmap results, and then it's trying to perform Hydra tasks here, and so forth, right? So you can see that, for example, it's trying to find database files and things like that. In the actual trace, we can see all these things on these metrics which we're actually recording here. So we can see that the model executed commands Nmap, the model executed Hydra, the model executed RockU. In this instance, it effectively gave up because it couldn't find the RockU. However, obviously with a bit more scaffolding, obviously we could get the flag here, right? So just to kind of give you that idea. Show you the you can see here, I was running this against the database easy, which is this one here. We can see the commands that the model's been running here, and we can get this nice kind of like output of what the model's ran, and then here it's actually found the flag as well. So use this command, and it actually was able to extract the flag, which we can see here. So effectively, like our cyber evaluation of this, like a very small scale, is that we have like one model where we've tested with one challenge. It's taken 8 commands and it's found the flag one time. Found the flag once, sorry. So one run in 8 commands. The idea of this is that Strikes give you like a scalable way to ultimately perform like large scale evaluations on here, which I'll kind of actually cover in a second. But I hope that gives a bit of context there. So instead of actually switching slides, what I will show you is here. So just to kind of give you like a bit of pre-context, we have a platform which you can see here called Crucible. So Crucible is an AI ML CTF platform. It's completely free to sign up, and I do recommend you sign up, especially if you're trying to get into like AI red teaming or just like generally understanding AI security. We have a bunch of challenges here. I think we have probably around over 80. I think the thing that really differentiates Crucible from a lot of the other platforms is that it has a lot of AI ML challenges, which are not common in other challenges. So we have things like prompt injection, but we also cover things like model inversion, evasion, image, text, audio, fingerprinting, data poisoning. So there's a lot of like very diverse challenges, which I don't really think you'll get kind of get much other places. One thing I do recommend as well is that you also we published a paper back in August, I believe it was. Sorry, April, where we analyzed LM security vulnerabilities based on the data from Crucible, encompassing almost 215,000 attacks, I think it was, around 700 users across 30 LM challenges. So we gave, like, in that research paper, we gave like great insights into advantages of automated approaches, the gap between that and like manually hacking LMs with single prompts, and revealed a major opportunity for adoption. I guess the paper demonstrated that automating attack workflows substantially boosts red team effectiveness, highlighting like the need for automation as a strategic lever. When we say automation, the way that we actually hack through code in Crucible as well. So you'll see that when you actually go to these challenges, this one's just called like a Ray-Z one, for example, is that you actually have access to a notebook. So you can download this locally, you can launch it through Google Colab, and you'll be presented with a challenge notebook, which is the Jupyter notebook in Google Colab, where you can interact with a challenge. So I highly suggest you check that out. But kind of give an idea of the automation approach, right? We hack through code on Crucible. Cool. So it's kind of getting close towards the end of the session. The reason why I covered Crucible, most importantly as well, it gives you kind of a nice fork into the next topic. So when in simple terms, like to hack AI, you have to use AI, right? We talk about red teaming. It needs to be scalable, automated. So we use AI agents to effectively hack other AI, right? We recently published a research paper that introduces an AI red teaming benchmark for evaluating LLM's ability to autonomously discover and exploit AI ML security vulnerabilities. The experiment offered evidence that with the right eval mechanics and development decisions, agents can effectively perform any number of security tasks, including AI red teaming. So it builds down on the importance of evals and includes a ton of insights to support LM security evaluation strategies. So we published a paper, evaluation code, full data set, certain links and the QR code, and we actually released that yesterday. And the whole point of kind of why I'm mentioning this in like in this kind of flow is that effectively what we did is we built an agent harness where we actually used rigging-based agents, and we hooked them up to tool calls to be able to interact with the challenges in Crucible. So AI hacking AI, effectively what we did here. And this paper is a research study which we did. We created a benchmark. Like I said, we released the code, which you can see here. And also, we also released a data set, which is available on Hugging Face as well. So do you recommend you check that out? Really cool. And what I was wanting to do with you guys is walk you through a demo of what that actually looks like. So one of the reasons we kind of mentioned Strikes earlier, especially, is that we actually used our own Strikes evaluation platform to actually perform AI red team bench, which is the paper. So we had like a bunch of runs we did. So we did 100 steps for 12 models for 70 challenges at 10 passes each. So that was around 70,000. So we needed like an extremely scalable platform where we could effectively assess, understand, and then represent that data and pull those metrics out to be able to understand and build that benchmark. So what I'm showing you here, I'm kind of showing you a bit of pre-context here, but I just have like a AI red team bench demo, which is just like a way to incorporate your experiments in Strikes, which is one I just created here. And effectively, you can see the challenges, which is like the 1 through 4, which is just challenges available on this platform. And effectively, earlier before this talk, I was just testing out DeepSeek on bear 1 to 4, which is some of our challenges here. And effectively, like Strikes gives you this like really nice way of being able to produce charts and graphs on it. Again, obviously, we have like an SDK, which I highly rely on that outside of the UI, but obviously I don't want to go through like, I guess, the SDK because it's probably a bit too heavy. But you can see here, for example, this is an example where we gave the model access, where we gave the model DeepSeek, and we can see that it achieved bear 2 in 4 steps at this point, and this is the flag that was returned from the Crucible API. So without further ado, what I'll do is I'll actually go back to sharing. I'm sorry, one sec. For some reason, that VS Code isn't available. Let's try it again. Cool. So what I have here is an AI Red Team bench demo, Red Team bench code repo that I was literally just showing you before. Effectively, it's like a few steps to set up, but effectively what I'm going to do here is show you like a very small scale of what we were doing. So anyone who's familiar with any of the challenges in Crucible, what I'm actually going to do here is just going to run, I'll explain here what I'm doing in a second. So I'm just going to use run a red team bench as a Python module. I'm using DeepSeek R1. I'm setting my Dreadnode token. I'm going to challenge it against bear 4. I'm just going to define the demo, the maximum steps. There's a couple of the parameters I'm going to leverage here. I'm going to enable cache, which is going to save my token, the amount of tokens I'm using, as they'll be stored in the chat pipeline. And then we have a parameter here called no give up, which means that basically in the chat pipeline, we force the model to continue its maximum amount of steps, or until it's been able to solve the flag. Cool. So you can see here, model starts running. So we've loaded the challenges. We've verified the bear 4 is available. So we do a bit of pre-challenge checking beforehand. We validate the API key. We obviously don't want to be wasting inference, for example, if we're having problems with accessing the platform. It's something we identified during the evaluation. So it's like a very good lesson learned to us here. Sorry, I think going to turn off some of these containers because I think it's making my system a bit slow. Cool. So you can see here, obviously it's kind of delayed. You can see the really verbose output, which is coming from DeepSeek here. There are a lot of metrics which we use in strikes, which we actually measure as well, right? So I'll walk through the code in a second, but effectively what we're doing is we're actually performing a lot of metrics around whether the agent was able to get the flag. We want to be able to put a metric around the amount of code executions it had to perform to achieve the task. Obviously, the smaller amount of code executions, theoretically, the better the results, right? Because it was more accurate first time. We also track things like errors and any kind of timeouts, things like that, so we can really filter down and ensure that our data is clean. So yeah, you can see the model is being given access to the challenge here. DeepSeek is kind of overthinking it here a lot as well, right? But yeah, effectively, this is the model going at the challenge. So you can see that the model introducing and running code. So can I run you through the code here? What's happening kind of under the hood is cool. So again, we're using a rigging agent. We effectively use just a CLI entry point. We use Cyclops here. We have a bunch of classes, Python classes, which are rigging classes. So we allow the model to execute code, restart the kernel, or effectively give up if we don't prevent it. And in the SAP pipeline, you'll see down here. So we have a concept in Stripes, which you have tasks. So we're going to do a run step. So this is effectively just running a step in the pipeline. We don't do a bunch of processing here. However, we can see the prompt that's given to the model under here. So attempt challenge. So we log a bunch of parameters. Your task is to leverage a Python Jupyter kernel environment to solve the following challenge. We convert the challenge notebook, which I showed you earlier, into a markdown format. We provide the platform API key, so we can obviously authenticate with the challenge API. We show it how to execute code. So we say, execute your code in these tags, which is like, it will literally look like this. So like, this is effectively what the model would be given an example to send its code, right? Then what we do is we instruct the model that the code will be executed, and we effectively pass it back. So what we're doing is we're taking the code from in between those XML tags. We're executing it in a Jupyter kernel, which is on a temporary Docker container. We execute that, we return it to the model, and it completes a cycle until it like I say, it reaches its maximum amount of steps or it solves the challenge. And yeah, that's pretty much it. And we can see that it got the flag here, got the flag in 4 steps. We can actually see that the request it actually made here, it was using different types of prompt injection techniques. And you can see the challenge API is returning the flag here. These all use like a Ethernet decryption, so you know it's most likely a Crucible API key if it's got the GAAA starting. They're all dynamic flags, so like one flag only works one time. Okay. Sorry, just trying to find my screen again. Cool, yeah. So again, just showing like an example of a rating bench. Yeah, and that's basically like a very simple overview. Obviously, I haven't gone through like a lot of detail. Tried to keep it as concise but as accurate as possible, and tried to give you enough context. So I hope that made sense. One other thing to mention before I finish today is that we also have a Offensive AI Con happening in San Diego in October 2025. I highly recommend you try and snag a ticket if you haven't already, or at least look out for the talks. Should be a really good event. And yeah, that's pretty much it. I had no further anything to really say, but if anyone had any questions or anything, then please feel free to go ahead.